Hey everyone, how are you? Welcome to another fun PyTorch mini project, and this is the project number 3 in the 50 projects PyTorch series. In this project, we are going to classify flowers with AI and we are going to use the Irish dataset for this. We have already seen some regression problems, some regression projects where we were trying to predict a continuous value. Now we are going to predict a categorical value. This is called a classification problem where we are trying to predict a category of values instead of a unknown continuous value. We will teach an AI model how to identify different types of flowers, different types of Irish flowers based on the measurements. Now this is a multi-class classification problem where the model must classify the input into one of the three flower species, Setosa, versicolor and virginica. Now let me show you how this flower will look like. So this is one of the example of the Irish flower where you have a sepal and you have a petal. Now a flower has a sepal, has a petal and it has some measurements. The length, the width, the sepal length, the sepal width and the petal length and the petal width. These four measurements, these four values are given in the Irish dataset and we are trying to predict is this flower a Setosa, versicolor, virginica. These are different species of a flower. What we are going to do is we are going to understand the concept like a story and we are going to code with all the best practices. We are also going to have some visuals like graphs, heat maps, and we are going to do the evaluation of our model using accuracy and confusion matrix. At the end of this project, we are also going to see some quiz problems and this is what you can gain. You can see how good your knowledge is after this particular project. Now, imagine you are a robot who is working in a flower shop. And if you are given some measurement of a flower, the sepal length, the sepal width, petal length and petal width. Again, this is the flower, this is the sepal, it has a length, a width, this has a petal, it has a length and a width. So if you are given the sepal length, sepal width, petal length and petal width and your task is to predict the species of a flower. These are the three species, Setosa, versicolor and virginica. Now can you predict it? Can you find what's the species of the flower based on these inputs given to you? Well, how will you do it? You will actually learn by examples and that's what machine learning is all about. You have some defined examples, some defined training data. You learn that okay, different sepal length and sepal width, petal length and petal width gives you different classes of flowers. Based on the data on which you have learned, if you are given a new measurements, you can try to predict the values, right? And the thing is guys, we are using the Irish dataset because it's like the hello world problem for classification. If you want to learn about classification, this is one of the problems, one of the dataset on which you will definitely be working on. So let's start with this. First of all, let us talk about how this setup is done. Where are we going to code? We are going to do our coding. We are going to create our project on a Jupyter notebook. So if you have not installed the Jupyter notebook, I have created a video on how to install the Jupyter notebook. You can find the video link in the description. But in short, what you need to do is you need to run this command, pip install notebook. Once you run the command in your terminal, Jupyter notebook will be installed. And if you want to open a notebook, this is the command, python 3-m notebook. Also, we are going to use some libraries like PyTorch, NumPy, Pandas, scikit-learn, matplotlib and seaborn, and you must install it before, right? So this is the command to install it. Now, if you want to install it using a terminal, you can use this command without this exclamatory mark. But if you want to directly install it in the Jupyter notebook, you can just copy this command and run it in your code block and this will install all the libraries, all these mentioned libraries. And guys, you can find this notebook in the description as well. So you don't need to just pause the video and copy the command or type the command. You can open that notebook and see the command, copy that command and run directly. How are we going to learn is, how are we going to create our project is, we are going to write our code and the moment we need a particular library, we are going to do our import. So we are not just directly going to import everything and then we start our further part. We will write our code and the moment we need a particular library, we will import it. So let's leave a block of code for importing our libraries. So importing the libraries, right? Now the next thing is, first of all, we need to load our database, the data set, right? So we need the data set and for that we are going to make use of scikit-learn module. You don't need to have this data set or download the data set because this module already has this data. How can we load the data? We can say Irish is equal to load underscore Irish. This load underscore Irish function is available in the scikit-learn module. So let's import it from sklearn.datasets import load underscore Irish. So now you have the Irish dataset in your notebook. You can run this import code and then you can run this code and you can see that Irish variable is now holding the data for Irish dataset. First of all, we need our input data, right? We need our sepal length, sepal width, petal length and petal width. So we can get it using irish.data. This will have your input data or your features. So you can say x is equal to irish.data. And what about the target? What about the different species of flowers, Setosa, versicolor and virginica? You can get it using y is equal to irish.target. So now you have your data. X is holding your features, y is holding your target. You can run this code, and now let's actually see how this data will look like. So first of all, let's print the value of x. So you can print x and you will see that this is how your data looks like. Now it is hard to understand this data, so we are going to make use of pandas to understand our data first. So let's get rid of this print statement and let's go on a new code block. And now we need pandas, right? So let's import it. Import pandas as pd. Now let us see our data. Before you move on this code block, you need to run this code block again because we have just updated our code. So let's run this code and then let's load our data, the x and y, as pandas data frame and series. So what we are going to do is, let's say df is equal to pd dot data frame, and this is going to convert our x data into a data frame. And let us say tg, which is like a target, is equal to pd dot series, and let's pass y into this. Now the thing is, data frame stores data in 2 dimension and series stores data in 1 dimension. Now how do you know that x is 2 dimensional and y is 1 dimensional data? So we can see the shape of our data, right? So x dot shape, if you will see, it has 150 rows and 4 different columns. If you want to see the shape of y, you will see y dot shape, and you can see it has 150 rows, just one column, so this particular value is not present, right? And this is how I know that this x is 2 dimensional, and that is why I'm loading it as a data frame. I'm loading my y data as a series. Now let us analyze our data. Let us see our data. So df, let us print the df, and now you can see this data in a visibly good way. You can see that we have 4 columns which are numbered as 0, 1, 2, 3, and we have around 150 rows. Now these are our data through which we are going to make our model learn about how different sepal length, sepal width, petal length and petal width affect our flower classification. So we have these 4 columns, right? Now what about the TG? Let's see our target data. So TG is a series and it has lot of values, like 150 values. So for every row in our X data, we have a Y data, right? So for every input data, we have a output data. Now we are not able to understand our TG data. So what we can do is TG dot value underscore counts. Now since we are doing classification, I know that there are some limited set of classes in my data which are numbered as 0, 1 and 2, which is for Setosa, versicolor and virginica. These are the 3 different classes of flowers we have, right? Now let us run this code tg.value counts, and you can see that the class 0 is 50, class 1 is 50 and class 2 is 50. It means we have around 50 data for Setosa, 50 data for virginica and 50 data for versicolor. So we have a good distribution of data for different classes we have, right? And guys, you can also see the feature names, right? So right now what we can see is just 0, 1 and 2, right? These are the classes. But how do we know the actual name of the classes? We can get it from the data irish. So we can say irish dot feature underscore names. These are our input data. So we have sepal length, sepal width, petal length and petal width. So if I will print this df again, here you can see that we have 4 columns, 0, 1, 2, 3, right? So this sepal length is 0, sepal width is 1, petal length is 2 and petal width is 3. For target also you can see that. So target names, and these are your different targets, Setosa, versicolor and virginica. So now you can see these are your targets. 0 is Setosa, 1 is versicolor and 2 is virginica. So now we know about our data, right? Next thing is we need to scale our data, because if I show you my data df.head, if I show you the data top 5 data, you can see that different features are having different scales of values. The first feature 0 is 5.1, the second feature is 3.5, the third feature is 1.4, the fourth feature is 0.2. So they have different sets of values, they are not on the same scale, right? So we need to scale our data, and let's actually do it. So let's create a standard scaler, and to scale our data we are going to make use of sklearn.preprocessing. So from sklearn.preprocessing we are going to import this module, import standard scaler. Using this we are going to scale our data. So again we need to run this code, and then let's start scaling our data. So first of all, let us create a scaler. Scaler is equal to standard scaler. First of all, we need to train our scaler how to fit our data. So we are going to train it on our input data. So let's say x, which is this one, let's convert it, let's scale it. X is equal to scaler dot fit transform. Now we are also fitting our data and transforming our data x, right? And once we have done this, let's run the code. And now your x data will look a bit different. See, this is your x data right now, which is really different from what we have seen. It was 5.1, 3.5, 1.4, 0.2, 4.9, right? But this is scaled to a different set of values. Now if you run this code again, because you have x updated, this will be totally different. Let us run it again, and you will see that these are different values we are having, and the range of values you will see are very much similar. This is minus 0.9, this is 1.01, this is minus 1.34, this is minus 1.315. Now the thing is, all my data looks very much similar, right? Because my data is scaled, right? We have scaled our data. Now let's split our input data into training and testing set, because we don't want to train our data on all the 150 data we have, right? So let us do it. And to split our data into training and testing, we are again going to import another thing from sklearn, which is from sklearn dot model underscore selection. We are going to import train test split. This is going to help us split our data into training and testing. So let's actually do it. What we are going to do is we are going to say x underscore train. This is our training data, the input. Then we have the input testing data, x underscore test. Then we have y underscore train, which is our output training data, and we have y underscore test, which is our output testing data. Now let's make use of train test split, train underscore test underscore split, and in this we need to pass our data. This is the input data x, this is the output data y, and now what's the test size do you want to keep? So I would say test underscore size is equal to 0.2. It means 20% of my data will be my testing data. And let's actually keep a random state so that every time we run this code, the split is same. So random state is equal to 42. Let's run this code. And now it says that train test split is not defined. Why? Okay, so we missed to run this code. Let's run it. Now I think this will be available. We can run the code again, and this time, yes, we have split our data into training and testing. Now if you will see x underscore train dot shape, this is 120 instead of 150, because other 30 data is now our testing data. So you can see the x underscore test dot shape, it is 30, right? So we have 150 data, 80% of it is training, 20% of it is testing. Now the next thing is, since we are using PyTorch, we need to convert our data into tensors. That's what PyTorch work on, right? PyTorch works best on tensors. And right now what we have is, we have this data, the type of our data is nd array. So instead of passing the nd array, which is in NumPy, we need to pass the torch, the tensors to our torch model, right? So let's convert these data into PyTorch data, which is tensors. So first of all, x underscore train, which will be equal to torch dot tensor. This is how we create a tensor in PyTorch. Then pass your training data and also specify the data type. So data type is equal to torch dot float 32. Now the thing is, we also need to import torch, right? So let's do it. We need to say import torch, and let's actually add some space so that we can know what different modules we are using. So this is pandas, this is torch, this is PyTorch, and this is sklearn. Now we have this training data converted to tensor. Let's convert our testing data as well. So actually let me copy the code. This will do it faster. This is for testing data. This is for training data. This is for my output training data. And this is the output testing data. We need to change it here as well. And this will be y train. This will be x test. So now we have written a code to convert all our data into tensors. Run this code. And again we have done the same mistake, which is fine. We just need to run this code again, the importing code. And why I am doing this is because I don't want to just randomly import everything and later on use it. If I am importing it just the moment when I am using it, this is how you will know better that which particular library I need at what particular moment, right? So it's fine, we are having these kind of errors. Once we have done the importing, we can again run the code, and this is fine now. So now we have our data ready. The next part is we need to create a model. So now let us actually create that robot, which is our model, and let's call it as Irish net. This is the name of our robot, the model. Now the parent class for this model should be nn.Module. This nn is neural network module in PyTorch. So let's actually import it. Import torch.nn as nn. Run the code. We are not going to do this mistake again of not running this code, which is good. Now once we have this module available, torch.nn as nn, we can say our class IrishNet will have this class as the parent, nn.Module. This will make this particular IrishNet class as a machine learning model. Now the next thing is we need to define some methods. So first of all, it is def underscore underscore init underscore underscore. This is where the constructor of our model is created. This will have a variable or a parameter called as self. And first of all, we are going to say super. Then we are going to call with our class IrishNet comma self dot underscore underscore init underscore underscore. This will activate your class as a machine learning model by initializing the important parameters in the module. The next thing is we need to create a variable self.fc is equal to nn.Linear 4,3. Now what is this? It's very important to understand this one, right? So the first thing is this fc is a simple instance variable of our class IrishNet, and this is a linear model. We have created a linear model nn.Linear which can take 4 data as an input and it can produce 3 data as an output. And why are we doing this? Because in input we have 4 features, right? And let's go back to our data. We have 4 features: sepal length, sepal width, petal length, and petal width. So we have 4 input. and the 4 input can produce 3 different output. Either it can be Setosa, versicolor or Virginica, right? And the different classes are 0, 1, 2, right? Setosa is 0, versicolor is 1, Virginica is 2. So this is the linear model we are creating, 4 inputs, 3 output, and we are assigning it to an instance variable fc. So this is our linear model. Also, let's create the method def forward. This method will be called when we are actually doing a prediction. So this will be self comma x, and this x is going to be our input, and this x should be having 4 different data. That is, it should be an array of 4 data, because what we are going to do is we are going to say return self dot fc, and we are going to pass this data. So if we are passing this x, this should have 4 data so that it can produce 3 different output. So we have created this class. Let's actually create our report, which is model is equal to irish net. This is our model, right? You can run this block of code and you have your model created. Now the next thing is we need to train our model, right? And before we actually start training our model, you remember in our previous videos we were creating the loss function and the optimizer. So first of all, we need to create a loss function for our model, and this will be equal to criterion, let's call it as criterion, which will be equal to nn.CrossEntropyLoss. Now why are we going to use the cross entropy? Because in regression problems we were using the mean squared loss, right? The thing is, when it is about classification, cross entropy loss works really well. And the optimizer which we are going to use is equal to optim.adam. Now you don't know about optim, right? So first of all, let us import it. We are going to say import torch.optim as optim. Run the code and let's come back again. So we have this Adam optimizer, and we need to pass the model parameters in our optimizer. So we can say model.parameters, and the learning rate will be 0.01. You can run this block of code and you have your loss criteria ready. You have your optimizer ready. Now we are good with our training. We can start the training now. And guys, I like the training part the most. The training part is the best part in the machine learning model. So let's start. We need to create a variable epochs, and this will be equal to 1000. Let's say, okay, let's actually do it as 100. Let's actually train our model for 100 times. We are going to say 100, and let's create a variable losses is equal to an array or a list. We are going to measure our loss in our losses variable after every training. So we will have 100 different values in our losses after the training. Now let's run a simple loop for epoch in range epochs. And first of all, what we are doing is we are going to say optimizer dot 0 underscore grad. This will reset the values of our optimizer, because we want our optimizer to update the model parameters based on every unique trainings instead of just remembering everything. And next is we need to do the predictions. So let us say outputs is equal to model. We need to call our model without training data, right? So our training data is x underscore train, and then we are going to measure our loss. So loss is equal to criterion. This criterion is going to measure our loss. We need to pass our outputs, the predictions, and the real output, which is y underscore train. We have our real data in the y underscore train variable. And based on this loss, we need to say loss dot backward. This will do a back propagation, and then we can say optimizer dot step. Now this function, the optimizer dot step, is going to update the model parameters based on the recent loss. So every time we are going to improve our model. The next thing is we also need to add this loss in our losses. So let us say losses dot append loss dot item. This item function is going to give us the actual loss value. And now if epoch mod 10 is equal to 0, that is after every 10 trainings, if we are doing the training for 100 times, after every 10 number of trainings, let's actually print the value of loss. So let us say print epoch. Let us print the epoch number, which is epoch, and then also print the loss, which is loss is equal to loss dot item. Now we should have it as a f string, and that's it. The training is ready. Our model is ready to be trained. So you can run this code and wait for some time. And now it says that expected scalar type long but found float, which is fine. We are going to understand the error and we are going to correct our code. So the error is, it says that expected scalar type long but it found float. Okay. Line number 7, which is loss, this one. Okay, I think this is expecting this y train as a long and not float. So let's actually convert it. Okay, so what you can do is you can run this code again, the training and testing split again. And next is what you can do is the y training and y testing. Let's make it as long instead of float 32. Let's make it as long. Run the code again. And now let's go back to our training again. Let's do the training. So once we do the training, okay, so we have done one more mistake. A small mistake is we need to say loss dot item, and we need to call this function. So let's run this code again. So now this training is perfect. Okay, fine. Let's do one more thing. Let's actually run the model creation code again. Okay, and this criterion and optimizer code again. Let's run it again. And now we need to do the training, because what happened is, so once we run a code, it already got trained for 100 times. So we don't know about what the loss it had when it was trained for the first time. So now we have this training ready. We can train our model. So let's run the code, and now you can see that we had a loss of 1.8, then 1.44, 1.12, and it got reduced to around 0.472. So at the start of the training, the loss was around 1.8. After the training, it is around 0.472 something, right? So the loss is decreasing, and that's what we need to do. We need to make sure that the loss keep decreasing. Now let's do one thing. Let's actually train the model for 1000 times instead of just 100 times. So what you can do is you set the value of epochs as 1000 and only print the loss after every 100 trainings. So epochs mod 100 equal to 0 should be the condition. Let's run this again, and now you will see that the loss, which was around 0.45, it got reduced to 0.1, which is a really good thing. So now our model is ready to actually do the predictions on our testing data. And now before we actually do the predictions, let's actually plot our losses. Let's actually see how our losses will look like in a graph. This will give you a good picture of how a model learns, how a model gets trained. So you can say plt.plot, and before you actually use this plt, we need to import it. So let us get back to importing, and you can say import matplotlib.pyplot as plt. Run this code. Let's go back to the code again. Now we can do some plotting. So you can say plt.plot losses. Hit enter, and now you will see that this is how our loss is decreasing. It was around 0.45 when the training started, and after 1000 trainings, it got, you can see this curve. You can now see how the losses are getting decreased, right? And this is a good thing about plots, graphs. We can visually understand how our training is happening, how good the training is happening. Now if you want to improve this plot, what we can do is plt.title. We can add a title to our plot, and let's make the title as training loss curve. Also let's add a x label, plt.x label, and let's call this x label as epochs or training. Let's say training number, and plt.y label should be loss, right? Next is plt.grid. This will be really good. If you will see, you will find it really good. plt.grid as true, and let us say plt.show. That's it. You have a good code. Now you can run it, and now this graph looks really good. We have a graph title, the x label, the y label, and we have a grid which is giving us a good picture of how the losses are getting decreased, right? Now let us do some predictions. Now we are talking, right? Now we are going to do some really good thing. So what we need to do is we need to say with torch.nograd. We don't want any gradients to be calculated, and the thing is, the calculation of gradients takes some memory, takes some power, and when we are doing some predictions, we don't want to use those powers. So now we can say preds, which is the predictions, is equal to model x test. Let me run the code. Let's see the value of preds, and if you will see the value of preds, it's a bit different than what you were expecting, right? You were expecting Setosa versicolor or virginica, or maybe 012, so that I can understand if my current data is of Setosa versicolor or virginica. But right now what I see is an array which is having 3 different data. Now let's come back to our model. The model says that I can take 4 data as an input and 3 data as an output. So what I am having right now is I am having 3 different data in my output. These 3 values are telling me what are the chances of a value of a particular input being Setosa, being versicolor, or being virginica, right? It is trying to give you a value through which you can understand what are the different chances that this particular input belongs to which class. So you just need to take the maximum out of it. This is your output. You can say that the chances of class 0 is minus 3.5, the chances of class 1 is 2.5, and the chances for class 2 is minus 0.24. Obviously the maximum value is 2.5. So this output, this particular prediction is telling me that this particular input of data belongs to class 1, because for class 1 the value is maximum, right? Now you don't need to calculate it, you don't need to do some logic to get the values. We already have it in PyTorch. So let's update the value of our predictions, and let us say preds is equal to torch.argmax. Now let me actually run the code, and then I will show you how this particular argmax works. In this you need to pass the value, the preds, and the dimensions. It has 1 dimensions, right? So dim1. Let's hit enter, and now again let's print the value of preds, and now the values are 1, 0, 2, 1, 1, something like this. Earlier it was something like minus 3.5, 2.5, and minus 0.24, right? What it did is it converted this value to 1. Now the thing is how this worked, how this particular thing, how this argmax function converted this data into 1. It just found out what's the maximum value of this. The maximum value is 2.5, which is at index 1. So yes, the output for this is going to be 1, and that's it. Argmax works in this way. So now you have the predictions 1, 0, 2, 1, 1. These are the different classes of output you are having. Now we don't know how good or how bad our model did, right? And that's the main part. We need to understand how the predictions of our model is. Let's actually see the report of our model using classification report. So that's something which is in the sklearn module. So you can go to the import section again and you can say from sklearn dot metrics import classification report. Now this classification report is going to help us create a report on how good our model did by doing the classifications. So now let's call this function classification report, and in this you need to pass our actual values. Our actual values is in the variable y underscore test. The predictions are in the variable preds. And what are the different target names? So target names are, let us give the target names as Irish. This is our data which we got from our sklearn module. So this is how we got the target names, right? So we need to pass these target names as well. So it will be Irish dot target names, and that's it. And let's actually do one thing. Let's cut the code and paste it here. Let's run directly here. Okay, so now what you need to do is you just need to print it. Okay, print it, and now you run the code, and now you can see a really good report of how good your model did. For Setosa, the precision was 1, the recall is 1, F1 score is 1, support is 10, versicolor it is 1, 1, 1, support is 9. So these are the different classification reports which your model is having. The precision measures your false positives. 1 means there are no false positive for Setosa, versicolor or virginica. Recall means false negatives. So you have no false negatives for Setosa, versicolor or virginica. Now support means how many true samples did you had for each classes. For Setosa we had 10, for versicolor we had 9, for virginica we had 11, and our F1 score says that it's 1, which means our model identified each and every value correctly. The overall accuracy of our model is 1, which is 100%. So these scores are actually telling us that our model did really well, really good while doing the predictions. Now let me actually draw another graph to explain you how good our model did. So let us say weights is equal to model dot fc dot weight dot data dot numpy. Let's convert it to numpy, and if you will see the value of this weights variable, it is something like this. Now it's hard to read these values, but let's actually print a graph. Let's actually draw a graph, and then we will try to understand these values. So let's print the weights, and then we can say plt dot figure. Let's create a figure, and we are going to say the figure size should be 6 by 3, so 6,3. Then let's make use of Seaborn. Now the Seaborn is another module for plotting some graphs. So we can say import Seaborn as SNS, run the code again, and then come back to the code. Here you need to say sns.heatmap. Now let's create a heat map, and I will show you once the graph is plotted about everything, how this code is working and what we are trying to do. So let's pass the weights variable, annotate it. Yes, annotation should be true. And then let's have a C map, the color map of our graph, which will be like cool, warm. We have different color maps. Right now let's keep it as cool, warm. What are the X tick labels? So X tick labels, that is what are the labels in our x-axis? It will be Irish dot feature names. What are the different feature names we are having? And then what are the Y tick labels? That is the labels in the y-axis. It will be Irish dot target names, right? And that's it. Let's add a title to our graph, plt dot title, and let's actually give the title as linear layer weights. This graph is going to tell you about feature importance, how important a particular feature is for a particular target category. Let's show the graph, plt dot show. Okay, there's some minor mistake in this line. Okay, let's correct it. All right, so now we have this graph. This is the linear layer weights graph, which is telling us how important a particular feature is for a particular category of flower. Now what is this matrix? What is this graph? Now this graph is having rows. This graph is having 3 rows. The 3 output classes, Setosa, versicolor and virginica, and the columns are the input features, sepal length, sepal width, petal length and petal width. What you are visualizing right now is a heat map, which is telling us how important a particular feature is for each class. Let us try to read a particular value, 2.3. Now this 2.3 is for petal width for virginica. It means that this petal width, this particular feature is highly affecting virginica, and it's affecting it positively. Minus 2.2 is for petal width for versicolor. It means that petal width is actually affecting versicolor highly, but it is affecting it negatively. So there is a high correlation between petal width with virginica, versicolor and setosa. Talking about this value 0.77, which is negative, it means that sepal width has a less importance for versicolor. If you want to predict about versicolor, sepal width doesn't have a lot of importance as compared to other features, because the other features, sepal length is 1.9, petal length is -1 and petal width is -2.2. So this graph is telling me how much a particular feature is important to classify a particular class of flower. And that's it what we have right now, guys. This is the complete project which we need to create for classifying flowers using Irish dataset. Now it's up to you how deep you want to go on this data set, what different kinds of graphs we want to create. But right now what you just saw, what you just created is a complete end-to-end project for Irish dataset. So now let's come back to this section, the quizzes and takeaways. So talking about the takeaways, guys, you have just created this project, which is a really good project to understand about classifications. You can find this project code in the description as well. Now I have a quiz question for you, something which you can explore. Now, you know that we have taken this loss, the loss criteria, as cross entropy loss. In our earlier projects where we were doing regression, we were using MSE loss. Now the thing is, it's not actually a quiz, it's an assignment for you. If you are trying to use the MSC loss, the mean squared error loss, instead of cross entropy loss, how will your model do? And that's the thing you will have to do, you will have to see, and this will help you to understand how different loss functions will affect your project, affect your model. And make sure that you do this assignment, you check what happens if you are using the MSC loss, and do provide me your experience on this particular change. I really want to see it, I really want to understand the feedback from you guys. So let's actually do it. And that's it for this video, guys. If you like this video, if you like the project, if you are actually enjoying this particular series, then make sure that you hit that like button. And if you're not subscribed yet, then make sure that you do subscribe to the channel, because this is just the third project. We are about to create 50 different projects on PyTorch, and this is going to be really cool stuff. Okay, so make sure that you subscribe to the channel, and I will see you guys in the next video. For any questions, make sure that you use that comment box and give your questions, throw your questions on me, and I will try to answer each and every questions which you guys are having. So that's it for this video, guys. I will see you in the next video. Thank you for watching this video, guys.